So now you guys, we're going to take the numbers and the variables and put them together all under the same radical. Okay? So you have a to the third, b to the fifth, which we know both of these are not perfect squares. So we're going to have to break both of them down. So everyone draw your equals and draw the roof. It's going to be a long roof. Okay? So what times what gives me a to the third? You guys should be writing a squared times a. Right? And what to the what times what gives me b to the fifth? Well, it's going to be the highest even exponent times the leftover. Do you see what I just did? Okay? So, what are we going to circle? We're circling only the perfect squares to symbolize that that's what we're pulling out and taking the square root of. What's the square root of a squared? A. What's the square root of b to the fourth? B squared. What is still left over under the roof, you guys? A, B, and you're done. Okay? If we have any other questions, we'll go over it after we record the video. Okay? So that we can get the examples done. All right? So, next example. Hold on to that question. Here we go. What did we say this negative symbol in front of the radical means? Give me the opposite of whatever the result of this is. Well, you guys, let's not forget that negative, so bring it down, right? Why do we love x to the fourth and z to the sixth? Because they're both what? Perfect squares, right? So circle it, draw the arrow, circle it, draw the arrow. Is y a perfect square? No, because that's y to the first. So what times what gives me x to the fourth? X squared. What times what gives me z to the sixth power? Z to the third. And what is still left over under the roof? Ry, and you are done. Is this getting easier, you guys? The more examples we do, and the more practice we do, the easier it's going to get. Okay? So, let's put up the next one. 54 n to the 7th. Okay? There it is. Now we've got a number and a variable. Let me erase this. Under the roof. Okay? So, again, draw the roof. So, how you do this, you guys, when you have both under the same roof, when you have the number and the variable under the roof, you have to deal with the number first, then the variable. So, let's deal with the number first. What times what gives me 54, but one of those numbers has to be a perfect square? 9 times 6. So, everyone write 9 times 6. Isn't 9 a perfect square? Yes. Now, is n to the 7th power a perfect square? No. What times what gives me n to the 7th power? And we have to use the highest even exponent with it. N to the 6th power times n. Do you see what I've done? So I took care of the number first. That's why I said draw the roof. Okay? And then n to the 6th times n. So now we circle the perfect squares. We only circle the perfect squares because that's what we can take the square root of, and then we have to leave the leftovers, okay? So what's the square root of 9? 3. What's the square root of n to the 6th power? What times what gives me n to the 6th? N to the 3rd. And what is still left over under that roof, you guys? 6n, and we're done. Okay? It's that simple. Let's do this one. Last example. Okay, last example, I think. Yep. Okay? So, here we go. Are we just going to forget about this negative m?
Nope.
We're going to bring it down. Why? Because this is a negative m times whatever the result of this is. So let's bring it down right away. Do it now. Do it now. And put the times. So that multiply reminds you that whatever you pull out has to be multiplied to this negative m, because this is negative m times whatever the result of that is. Now we're going to draw the roof. So again, you have to use you have to take care of the number first and then the variable. And we have to use the highest perfect square that we can. So what times what gives me 80? And one of those numbers has to be a perfect square.
40 times 2.
Okay, so 40 times 2, neither one of those is a perfect square. So then you divide by 3, you divide by 4, you divide by 5. I think it's something 16 times 5. Can you do it? Try that for me. What's 16? What is 80 divided by 16 give you?
5.
Okay, so 16 is a perfect square. So we always use the highest perfect square that we can. Okay, and then what times what gives me m to the 9th? That's not a perfect square, so we have to put m to the 8th times m. Okay? Deal with the numbers, then the variables. So circle and circle. Again, you guys, before we end this, okay, let's remember that this is the most important lesson of the whole radicals unit, because if you don't know how to simplify after you add, subtract, multiply, or divide, you're going to get the answer wrong. Okay? So, what is the square root of 16? 4. Look where I'm putting it, you guys. Because whatever I pull out has to be multiplied to that negative m that was in front. We can't forget that that negative m was there. Okay? And what is the square root of m to the 8th? What times what gives you m to the 8th? M to the 4th. Now what's left over? What's left over? 5m. Are we done here, or do we have to clean this up? We have to clean it up. So a negative times a positive gives you a negative, and a negative times a positive gives you a negative. Okay, negative 4. And even though it's not there, you know there's a little 1 there, right? So m times m to the 4th gives you m to the 5th, radical 5m, and that is your final answer. Okay, so the clue is that you need to take care of the number first, break it down, what times what gives you 80, and then what times what gives you the variable. Okay? Fabulous. Thank you.